Let us solve some problems on probability. Yeah, as we looked earlier, the probability of an event that will surely happen. Um, Such an event is called a certain event. Now, if we throw a regular dice, okay, let us look at the problem now. If we throw a regular die, then getting 7, right? Whenever we throw uh, a regular die, we have uh, that is 1, 2, 3, 4, 5, 6, right? As the outcome. Getting 7 is impossible, right? Uh, is impossible outcome on a regular die. So the event is an impossible event. And we have looked earlier also that if P of A denotes the probability of an event, okay, then we know that 0 less than or equal to P of A is less than or equal to 1. So as the probability of the event can be between 0 and 1. Okay. Now I have an option as 1 by 3 and 1 by 2 and 5 by 7 and 17 by 16. So which of the following cannot be the probability of an event? Yeah, any guesses? Now if you look at 17 by 16, the probability always lies between 0 and 1, which I already discussed. So 7 by 16, this is greater than 1. So we have 17 by 16, which cannot be the probability of an event. And we also know that the sum of a probability of all the elementary events of an experiment, okay, is 1. Okay, so we have discussed this earlier also. So the probability of that is the probability of event E plus the probability of event not E, which is equal to 1. Okay. Now let us look at this. A die is thrown twice. Yeah. Now, what is the probability that 5 will not come up either time? Okay. So let us see the outcomes here. So the outcomes are 1 comma 1, okay, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, right? And now let us put 2 comma 1. Yeah, so this is 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2,6, 3,1, 3,2, 3,3, 3,4. Let me write this fast. Yeah, this is 4,1. Yeah, 4,4, right? Yeah, and 5,1, 2, 3, 4, 5, 6, and lastly you have 6,3, 6,4, 6,5, and 6,6. So the total outcomes, if you calculate this, so this would be 6 multiplied 6, which is 36. Okay, so let us consider here, okay, the following events, that is A as 5 and, comes in first row. Okay, comes 5 in first row. Yeah, and B is 5 in the second row. So that is P of A, the probability of event A, which is 6 by 36. Okay, and P of B, which is 6 by 36. Okay, and P of not B, okay, not B, so which is 5 by 6. Okay, and P of not A, which is 1 minus 6 by 36, which is again 5 by 6. Okay, so the required is probability, which is 5 by 6 multiplied 5 by 6, which is 25 by 36. Either you can solve like this, or there is another method. Let me show you. If you consider E as event, this is method 2, with the event in which phi does not come up. Phi does not come up either time. So the favorable outcomes, the favorable outcomes, which will be 36 minus 5 by 6, 5 plus 6. Within this bracket, so which is 25. So the probability of the event E is 25 by 36, which is the favorable divided by the possible output. So either you can solve any of this method. Now let us try to solve this problem. That is, a card is drawn, a card is drawn from a well shuffled deck of 52 cards. Okay, you got to find the probability of getting a red face card. So how will you do it? Okay, so we know that here there is the total possible outcomes, which is n, which is 52. Okay, so the favorable, which is m. Okay, uh, that is the red face, which is 6. Okay, we have that as 6, right? So it will be probability of getting red faced that is E will be 6 by 52, which is 3 by 26. So let us solve this problem. A bag contains lemon flavored candle only. Okay, candies only. So Malini takes out one candy. Okay, without looking into the bag. So what is the probability that she takes only lemon flavored candy? So as there are only lemon flavored candies, so the probability of lemon flavored, okay, which is only one, or the 100%. Okay. Now let us look at another problem. Find the probability that a leap year selected at random, okay, will contain 53 Mondays. Okay, let's solve this. We have to find the probability that a leap year selected at random will contain 53 Mondays. So in a leap year, the total number of days, which is 366. Okay, and 360 days, which is equal to 52 into 7, okay, plus 2, which is 52, which is equal to 52 complete weeks, okay, plus 2 days. So thus a leap year will always have 52 Mondays, but the 2 extra days can also be Monday. So thus the extra days can be Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, okay, and Thursday and Friday, again Saturday and Sunday, Sunday and Monday. Okay, so let E be the event that the leap year has 53 Mondays. So E will be, that is Monday and Tuesday, Sunday and Monday. Okay, so P of E will be 2 by 7. Okay. Now let us look at another problem here. Now a urn contains white, black and red balls only. Okay, a ball is drawn at random. Okay, let us see this. From the urn, okay, if the probability of getting a white ball, okay, is 3 by 10, okay, and that of a black ball is 2 by 5, is 2 by 5. Then we got to find the probability of getting a red ball. Okay, let us see this. So we have white, black, and red balls only. Okay, so the probability, we know that the total probability of the event, which is 1. Okay, the total probability is 1 in the given scenario. So it is given that probability of white, okay, is 3 by 10. Okay, and we have been given probability of black, which is 2 by 5. So therefore probability of white, so red, will be 1 minus 3 by 10 minus 2 by 5, which is 3 by 10. Okay, so that is the solution. Okay, please don't forget to subscribe. Thank you.